All right, going through 6 through 10, starting with number 6. A, given the conditional statement, write the converse. So what we want to remember is that a conditional statement is made up of a hypothesis and a conclusion. And that when you write the converse, you just flip them. So if the conditional statement is if two angles are congruent, then they have the same measure, then the converse is going to be if two angles have the same measure, then they are congruent. Good. So, is that true? Yes. No. And so then, because that is true, and the conditional statement is also true, then we're going to go ahead and go with the biconditional and say, okay, two angles are congruent if and only if they have the same measure. And what you want to remember is that with a biconditional, you could actually have it the other way and say two angles have the same measure if and only if they are congruent, because it doesn't matter. Number 7, angle A has a measure of 3x plus 31, B has a measure of 2x minus 6. A and B are supplementary. Keyword here is supplementary. Supplementary means they have the sum of 180, so that's what we're going to do. We're going to add them up. 3x plus 31 plus 2x minus 6, set it equal to 180. Combine our like terms, so we end up with 5x plus 25. Subtract 25 from both sides. Divide by 5. So x is 31. But then it wants us to find the measure of both angles. So we got to go and substitute in. So we have 31 here. 3 times 31 plus 31 is going to give us a measure of 124. 2 times 31 minus 6 is going to give us a measure of 56. And again, if you just double check that, sum here is 180, so that fits the definition of supplementary. So moving on to number 8, find the area of the isosceles trapezoid. So what we want to remember here, area of a trapezoid is height times base 1 plus base 2 divided by 2. So height is unknown at this point. So what we want to think about here is that from here to here is 10. If this whole thing is 16 and it's an isosceles trapezoid, then the distance from here to here has to be the same as the distance from here to here, which means that these both have to be 3, so that you can have a sum of 16. Because your height forms a right angle, then we have a right triangle here, and we can say h squared plus 3 squared equals 5 squared, and so h has to be 4. So once we know that h is 4, we can substitute that in. Base 1, 16 plus 10, and again, addition is commutative, so it doesn't really matter which way you go there. And then we divide by 2, starts with the 2, divide by 2. 4 times 26, then divided by 2, is going to give us an area of 52 centimeters squared. So with number 9, we have our special right triangles. Start off here with the long leg of a 30, 60, 90. So if we have the long leg of 30, 60, 90, then we always want to go then to the short leg. To go from the long leg to the short leg, we divide by radical 3. So if you have 10 radical 3 divided by radical 3, they will cancel out, and this leg becomes 10. So x is 10. And then we want to go right here to z, because these angle marks here tell us it's a 45, 45, 90. So if this leg is 10, then so if this leg is 10, then so is this one. So z is also 10. So then we can go wherever we want. If you want to stay with the 45, 45, 90, we know then that from the leg to the hypotenuse is times radical 2. So that's just going to be 10 radical 2. So W is 10 radical 2. And if we want to go from the short leg to the hypotenuse, that's times 2. So then we just have 10 times 2 to give us a hypotenuse here of 20. So then number 10, area of a regular 7-gon with an apothem length of 29.1. So area is equal to the apothem times the perimeter divided by 2. Apothem is 29.1. Side length is 28. So we take 28 times 7 to get a perimeter of 196. So then we take 29.1 times 196 divided by 2 to get an area of 2,851.8 inches squared. And there is 6 through 10.